That's it. You got it. You got it.
We got it.
Okay.
We got it. Yeah.
Yeah, it was a little
Yeah.
arrangement.
Yeah. The
with
stream should have the PowerPoint now.
it does have it. Yeah.
That's what it shows now. All right.
Dude, we gotta do this. Dylan, dude. Yeah.
Just come on.
We gotta start.
Okay, 1 second.
All right. Awesome. Jeez. Technical difficulties.
You can see our menu online, cyberpizzacafe.com.
All right, guys. We're about to start off.
Yeah, you can.
All right. So this presentation. My name is Greg. I'm a malware analyst, and this presentation is going to be about YARA. I don't know if anybody knows or heard of what YARA is or how it's used, but we're going to go over some of the basics. I'm going to explain what it is, how to write YARA rules, how to use it, and we're going to go and do some hands-on as well, so we can understand how a YARA rule pretty much is written, how to break it down, and how to analyze a YARA rule. So like I said, some of the topics we'll cover is what is YARA, what's in a YARA rule, how to write them, how not to write them, how to use YARA. There are a lot of features that we're not going to cover today, but I'm going to mention them. And also the documentation website for YARA is fantastic. You can read it in like 30 minutes and pretty much learn about everything you need to know about YARA. And then we're going to do a little hands-on. Look at some rules, maybe write some rules. Okay, what is YARA? YARA is a tool aimed at, but not limited to, helping malware researchers to identify and classify malware samples. Because I'm a malware analyst, most of what I'm going to be talking about is from a malware analyst point of view. But you'll see that you can pretty much use this tool for anything. YARA uses pattern matching to describe behaviors or data. So what we'll see, you'll notice that we're going to be writing things that kind of look like what you would write on a command line to search for files or for strings, even on Linux. You can use grep and things like that. YARA rule, yeah. So YARA rules kind of mimic that kind of behavior. They just kind of put it in a nice little format for you to use. So what YARA allows the user to do is match certain characteristics or behavior patterns. So think of IDSs, like Pro IDS, Suricata, things like that. You write these rules that capture certain network behaviors. Well, YARA is kind of the same thing. It can work on any kind of data stream. You can tie it to a network based protocol if you want. You can use it as a host-based detection solution as well. And there's an interesting project for host intrusion prevention. Even you can use it almost like an antivirus, because all these rules are signatures pretty much. It provides a Python library, so if you're a Python programmer, it also provides a library and a framework to use it within your own code. Also, it provides a C API. Alright, so what's in a YARA rule? I'm going to talk about this stuff, but just keep it in the back of your mind, because once I talk about it, we'll actually get to see some rules. That way we can put the information into context. Basic YARA rule defines a certain condition. YARA contains a lot of keywords. Just like any programming language, there's keywords you can use within a YARA rule that you shouldn't use anywhere else. Just like any programming language, you can't use a variable called for or something.
Reserved words?
Yeah, reserved words, pretty much reserved keywords. Identifiers are like your variables in programming languages. Identifiers, you're going to assign these strings that you're looking for, and identifiers. And identifiers follow the same lexical rules as the C programming languages, meaning the first character of an identifier can't be a digit. You can use alphanumeric or underscores for your identifiers. The norm with most YARA writers is to use the dollar symbol with their variables, almost like what, PHP. Here are some of the reserved words. Actually, I think these are all of the reserved words for YARA. You can find these also in the documentation website. So we'll take a closer look at some of these. One of them is deprecated. I'll explain why later. Alright, so most YARA rules contain both strings and conditions. So you define strings that you're looking for, which is kind of the behaviors you're looking for, and the conditions are how you want to act against those behaviors. Strings can be a range of identifiers. So typically you'll be looking for plain strings, hexadecimal data, regular expressions, and a very primitive wildcard expressions and jump expressions. Strings can also be enforced by modifiers. So if you're searching for a string that's, say, Unicode, you can identify it. You can enforce the modifier by telling it to only look for this string as a wide string, all right, not as an ASCII string. So wide strings, you'll find those mostly in Windows binaries that use Unicode strings. If you don't put that modifier wide and you are looking for a wide string, that rule won't hit. By default, YARA looks for ASCII strings, so it's important. A lot of these modifiers are important. Full word is also another important one. If you put a string such as domain, and you're looking for a binary or a data stream with the word domain in it, and you don't put full word, it'll match any string with the word domain in it. Now, if that's not the behavior you want to enforce the modifier full word to only search for that data stream, for that string.
What happens if it's a packed binary?
We'll look at that as well. Typically you want to identify packed binaries by their packers identifiers. So UPX, for example, you'll search for the strings UPX because that shows up in the name section sometimes. Or we're going to look at a little more advanced ways to define a sequence of hexadecimal strings that can identify that packer. Every packer has a unique signature, and we can identify them from those. Alright, strings and modifiers. Like I was saying, I explained it in the last. Text strings and regular expressions can be enforced with modifiers. Right, so you can enforce wide to search only for wide strings. The note here is that it's not truly UTF-16 wide strings. So all it does is it looks for the ASCII and a 00 to cover that 16-bit rule. So if it's an actual true Unicode string with the actual 16-bit characters, you want to search for it in a hexadecimal, not as a string. Did that confuse anybody? Oh, alright. ASCII, no case, that just says not case sensitive, and full word. Regular expressions in YARA, it's its own regular expression, but if you're familiar with the PCR, it doesn't support is capture groups in regular expressions. Right, so the YARA documentation does provide a more in-depth look into exactly what the what regular expressions are supported in YARA.
They just support extended characters, meaning foreign languages, or it's just something.
I guess you could write a regular expression for it, but just like the wide string is not truly UTF-16, so it doesn't support actually different languages because some languages use the whole 16-bit width of the Unicode specification.
It's hex.
Yeah, search it by hex. I would search it by hex if you're doing foreign languages. So like you can't put Chinese characters in the quotes. All right, how do you write a YARA rule? So it's a text-based system. You open up any text editor and you start by writing your rule name, strings, and conditions. Before you start writing a YARA rule, obviously you want to already have an idea of what you're searching for. So that's the intelligence gathering phase. Get the strings necessary or get the data that you want from that data stream to capture more of it. In a malware point of view, you analyze one malware, find some unique characteristics of that malware, write a YARA rule, plug it into a system that has a large repository of malware, say VirusTotal or an antivirus company, and you can find all the matches of that same or similar malware based on that signature. So the rule name typically corresponds to the target you're trying to identify. So the malware family or the malware name or the text file or that picture you accidentally sent to someone you shouldn't have, whatever. Multiple rules can reside in one file. So it doesn't have to be one rule per file. You can write several rules in one file. The tag name, so you can also have a tag name next to the rule name. Tags are usually used to filter the output, and we'll see that on the hands-on. We'll see how the tags are related to separating the output. The strings. So when you're writing strings for YARA, you want to use uniquely identifying string data. All right. So the whole point is so that you're not getting false positives. So you don't want to use like I don't know. I'll have some good examples once we get to those slides. Be aware of statically compiled libraries. So for anybody who programs, you'll know that you can compile a program usually in a high-level language, either statically or dynamically. Statically is all the libraries are embedded into the executable, and dynamically is they load the libraries they need at runtime. You don't want to have strings that come from statically compiled libraries just because you might hit a lot of false positives. There's a lot of programs out there that could use OpenSSL library. So you don't want strings from the OpenSSL library in your strings condition, unless that's a unique identifier for that particular malware. Hexadecimal strings should contain also fairly unique sequences to minimize false positives. So you don't want to use a function prologue as a hexadecimal identification. So the function prologue is just the first sequence of bytes most functions have when they start up, like preserving the stack, push EBP, move EBP, SP. You don't want to use the byte strings for those because almost every function has that. So the idea is to find string data that can be found across all versions of the library, or the binary, sorry. So that's the idea. The idea is to find some strings that just pop out to you like, oh, maybe all the versions of this malware has this particular string. I'm going to use this to try to find more of it. And we already talked about modifiers. I talk about modifiers a lot because that's one of my kind of rule of thumbs. When you're using string data, use a modifier. It doesn't hurt to use them. You can use more than one at a time. You can use ASCII and Y together, which will let YARA search for either ASCII or the wide representation of that character. And forward is an important one. I would use it almost 90% of the cases. Alright, so conditions. So here we have just an excerpt of a YARA rule. You have the strings here. Here's your identifiers, the variables. Here are the string data, and here are the modifiers. Down here we have conditions. So conditions are the logic of your rule. These are kind of like the bread and butter here. Conditions are required on every rule. However, string data are not required. We'll see later how we can use a rule without string data, but only conditions to find certain behaviors or characteristics. All right. So in this we have a list of strings that I found in this piece of malware, use the full word modifier, and then in my condition, I only want to find 8 of all instances of these strings. Well, not instances, but only 8 matches. If I return at least 8 matches on this rule set, then that malware,
That resolves true.
yeah, it resolves to true. All right, so conditions, you can do a lot with conditions. We'll see later that conditions are kind of like that. That's where you really want to put your effort into your rules, right? So you can do things like relative byte distance. So if I have a stream of bytes or hexadecimal characters, whatever, and I know that sometimes the next sequence of bytes I'm looking for is 16 bytes away, I can write a YARA rule that can capture that kind of logic. So I have this bytes, 16 bytes separate. I want to only match if this sequence of bytes is 16 bytes far from.
What would be the purpose of that? Like, what if they had
If usually that's used in more like polymorphic code, so viruses can come in different forms. If you they have the same logic, but it comes in different sizes, different sequence of instructions. But there's some instructions you can't replace, or they won't replace. And so you find those. I'm gonna show an example of that when we do the hands-on. You can count occurrences of strings. So this, you have the identifier B equals a string. Now if that string shows up more than 3 times in a binary, we can write a condition saying the count of this identifier is greater than 3. So if that string shows up more than 3 times in this binary, we have a match. String offsets or virtual addresses. This is another important one. So if you know that a particular piece of data always shows up at offset 100 in that data stream or in that binary, we can say this identifier at 100 and this next identifier at 200. 100 and 200 are virtual offsets from the file. All right. Range base. So it's almost kind of like the relative byte distance, but this can show us
range of bytes.
a range. Yeah. So this you can constrain it to a range of bytes. So if you want to start from the beginning of the data stream or the beginning of the binary, all the way up to the 100th byte, that's the only place that this identifier can show up, and that'll equal to true. So you can do a lot of flexible things. You don't just search a string and hope you hit it or not. And there's many more conditions. All of them, any of them. So this covers all of the strings in your rule. This covers any of them. So if it matches 1, true. All of the A identifiers, or any of A, B, or C identifiers. So it's really a game of logic. If you know your Boolean logic, or if you remember discrete math, then you really enjoy this part.
Who publishes YARA rules for consumers? Like we can get.
You can find YARA rules in almost all security publications now. It's a public security publication. Usually they'll have it. FireEye, Kaspersky, GitHub. You can find them in GitHub. I have mine's public. So
And how close is to their signature file
what's that?
for AV?
It's not very close.
It's not really close?
No, it's not very close. The AVs, they use HIPS engines. They use a lot of different mechanisms. What's that one? I forgot what it was called. But
Heuristics?
yeah, they use the heuristics mainly. So you can actually write a YARA rule that behaves like an AV signature. That's what it is. That's what it is. It's just an open source and free way to do it. All right, because AVs, they have their files encrypted, they have their signatures encrypted and stuff like that. But you can find YARA rules in the public. That's what it was made for. All right, so we know how to write them, how not to write YARA rules. There are some things you want to avoid doing, so you don't write bad rules. Alright? Like I said before, don't use function prologues or epilogues as strings. Don't use the sequence that starts a function or ends a function, because most functions, if they were compiled in a high-level language, they're going to look the same. Avoid using inline versions of C standard functions. So sometimes you'll find that there's like a memset or mem0 implementation inside a function. Avoid those because those can be found anywhere. Anybody can roll out their own mem0 or memset functions. Those are not unique. Right? You want to look for unique patterns. Avoid common library names. You don't want to use kernel32.dll as a string identifier. Almost every Windows executable has that in it. Right? Avoid using register opcodes and long sequence of operations. This one's a little harder. This one's a little more complicated. But basically, if you have a sequence of instructions that uses registers, those register values can change. If, say, the malware author recompiles the malware or something. So you want to avoid those, and you can with YARA. There's masking values that you can use. So we'll see that in some of the rules we analyze. Very short sequences, short hex strings or replicated byte sequence. If you're looking for a code sequence, my rule of thumb is to keep it 5 bytes or more. For data, 4 bytes or more. Avoid sequence of the same bytes. So don't search for FF. That's going to show up a lot in some binaries, or not at all. But you're going to be wasting a lot of CPU cycles on that search. If the short sequence is important, use the count condition. So if you do have to use a really short sequence,
Find a lot of them.
find a condition that satisfies what you're looking for. So if it's a short sequence of bytes and it shows up, I don't know, 25 times or more, place that condition so YARA doesn't waste its time. Because you will get an error. There's an error called error too many matches in YARA, so you don't want to break your scanning. All right, so we're getting close to the end of trying to get to the hands-on. I wrote a document on how to install YARA. It's publicly available on a Google Doc. And gosh, come on. I guess I screwed that up. Here it is. So I wrote it a document. Well, I guess we'll put it on the YouTube video. Put it on YouTube. It's very simple to install YARA. Anyone can do it. All right, and I laid out the steps sequentially for you. And I have a little usage instructions just to get started. All right. How do I get back to my presentation? All right, awesome, works. All right, so using YARA. So we talked about writing YARA rules, but how do we use them? Right? There's a command line interface for it. There's a tool that comes with YARA that actually does the scanning. It interprets your rules, parses your rules, and you can scan against a directory, running process, memory, any data stream you want. You can run YARA rule against it. And the syntax is really simple. You have the rule file as your first argument, and then you have a directory or a file or a PID as your second argument. All right. The YARA also comes with a compiler. It compiles your rules down into bytecode. What that does is just a speed advantage. If you're processing a lot of rules a lot of times, you want to compile the rules and have YARA process the compiled rules. Because every time you run a rule, it has to parse it, reparse it, and then scan. So you want the compiled version of it. You can use YARA from within Python. That's beyond the scope of this particular presentation, but if you want, the entire documentation is right there. The C API as well is documented. And the preferred method is command line for most people. Large corporations, they probably roll out their own version of it since it is open source. So they probably have a modified version of it. And YARA is also integrated with a lot of popular and free open source tools. So Cuckoo, Sandbox, you can plug YARA into that. Volatility, you can scan memory, which is really useful. The volatility plugin is a really nice touch to memory forensics. Some of the features we didn't cover, external variables. You can write rules that only get processed if you pass an external variable to YARA, and that's through the command line when you're using YARA. So kind of, if you have a large rule set and you only want to run rules that satisfy this external condition, then your YARA rules will parse the external condition and only run that particular rule. You can write modules. This was introduced in YARA 3.0, which is a really great addition. One of the best additions YARA put is the ability to write modules. So it's pretty much extending YARA's abilities to scan. So there's already some that come out the box. PE module, which is able to parse PE files. Cuckoo module that can automatically upload, files that match a certain signature to Cuckoo automatically. ELF parses Linux binaries.
Yes.
ELF files. The magic, hash, and math. Math, you can do like entropy checks against data streams and stuff like that. Includes, which is another important feature that you guys should know about. If you write a lot of rules, you keep rules in a directory, you can just write one rule in a parent directory that includes all those files. And then you just run that parent rule. And so it includes all those files, and that automatically includes all these rules for you. I guess it's another organization feature. You can write private and global rules. So private rules are just rules that if that condition is met for that rule, then continue running other rules. Global rules kind of act almost as the same, but it's like a blanket rule. Check out the documentations. I think YARA is one of the best documented free open source tools out there. Alright, so stop talking theory and let's see if we can look at some actual YARA rules today. Streaming is going to be a pain. No. Oh goodness.
Forget the guy waiting here for
Oh goodness. I'm not sure which desktop 3. This stuff is really complicated to use. Why is it not working? Man. This again.
Where's the third one? This one? What? Thank you for calling service. Hello?
Rod, do you know how to
Hello?
freaking
Hello? Hello?
trying to just show
No, you put the wrong numbers. Thank you.
the YARA rules? We're gonna do some hands-ons.
Ready?
But,
Thank you for calling service.
Well, you have to just minimize that and move it over.
what is the screen though?
No, move it over. No, don't do
To
it.
where?
Just put it there.
It is, but why is it? What is that? Why is it not showing up?
That's your other desktop. So move it to.
Is it
Move to the right.
to the right screen?
Yeah. See if it shows up.
There's no other screen though. What desktop is that? I don't have 3 desktops running.
Well, if you don't need 2 desktops, this is what you need to do. Go into Systems. Then tell it duplicate. You go here and tell it arrangement. Mirror. There you go.
Okay. All right. So we've got the basic YARA rule. Like I remember how I was explaining, a YARA rule only requires a condition. It is the most basic YARA rule you can write. The meta tags, that's also optional. That kind of just identifies author things. You can put a lot of different things in the meta tag just to kind of identify your rule. But it doesn't affect the actual YARA rule. So remember when we were talking about the modules? So with the latest YARA, you can import a module, and then after that, you can use the functionality of that module. Also, remember I said we didn't need a strings. We didn't need a strings conditions or the strings section to write a useful YARA rule. For example, this YARA rule. If I wanted to find all the files that are DLL files in a directory or wherever, I can use the PE module, and in my condition, PE characteristics ended with PE.dll.
Stream is not showing it.
What is the live stream showing?
The live stream is showing your whatever is yeah, it's showing whatever's behind it. Yeah, that's what it's showing. Yeah.
This?
Yeah, what you see there in the box, that's what it's showing. The whole screen in that gray
Yeah,
box.
you may have to change the settings.
Where is that? It doesn't even have it. Display.
No. What is that? A setting?
Which one? The beach?
Yeah.
That in like 15 minutes.
Yeah, the guy is in within 15 minutes.
I want to stream just the.
15 minutes, 1-5.
What is
Yeah.
that?
Yeah.
I think that's cropping the size of the screen to the size of that.
Yeah. I'm looking for Sublime, but it's not there.
Yeah.
But I would have liked to just have that. It's showing this screen, the stream.
That's what it's showing right now.
So maybe I need to move the
You
this.
need to put that on display capture. See now.
I'll just put that there then. All right, let me know if you guys see this after like 15, 20 seconds.
Yeah, we give it to, yeah, hold on. Not showing yet. Whatever we did, no worries.
This is not showing yet.
No, it's not showing yet. Yeah, well, we need to show some line.
Yeah, so what we do? Display capture. Oh, do cancel. Yeah, do cancel. Cancel that. Okay. 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 All right. Display capture.
This is for the
Okay, so then move it. We gotta move the. We gotta move the Sublime text to that display capture.
thought it was there.
Did you move it into it?
What's it capturing? I don't even know what it's supposed to be capturing.
See if I have to go into display capture now. Click in there. No, it's still in there.
Where is it supposed to
Move
be?
it again. That's the one. See that?
Like it doesn't
Right.
show up there though.
See, hit him. No, he actually do the plus. Text or whatever. Window capture. Yeah. Man, this software's a pain in the ass.
It is, man.
Yeah.
What the hell? I don't understand why this doesn't just show up. Yeah, Team Viewer would have probably been
No.
better.
No, if you do that, then the stream fails. Display 1, display 2. It's almost like that. Yeah, delete that. Delete that. Okay, so what you got there?
Just this one.
It's almost like it's just showing the same thing again. You see that? So. Oh, it was moving right there. Uh huh. Move it. Do that, and then just move to the text.
Well, I'm just moving the screens over. It's not really. It's not showing what I wanted to show. Fuck, this is stupid.
See that? But when you watch,
It
when you
should
do this,
show
you
that.
see how it's moving now?
So this should show up.
Right.
I can see it. This is right there. You go.
Okay.
Okay. Now if you went away.
But it was
You
working.
move it, it show. Yeah.
So it should go back to this.
Yeah. You're good.
Okay. Ah, sorry guys. I don't know none of this equipment. All right, so here we use an import module, and then we only use the condition. This would return all files that are identified as DLL files. For this one, same deal. We wrote a rule. We imported the PE module. Here's where the tags go. So you have your rule name. Yes.
Can I stop you real quick? So you just said that previous rule that we looked at, if I ran that on a directory, it would return back every file in the directory that was DLL. So is Yara going through each file in that directory and then looking at the binary itself and then matching on any conditions that you would have put inside of your rule? And
Yeah, so it passes the data stream.
mm-hmm.
Yara passes the data stream to the rule. In this particular rule, the PE module also processes the data stream. And the PE module is built specifically to identify characteristics in a PE file.
Right.
So when it checks the condition against that chunk, that data chunk, it sees, it knows where to look for that particular characteristic
Gotcha.
in the PE file header.
That was built into the PE module.
Yeah,
Gotcha.
This is built into the PE module. If you don't import PE, you can't use this
Gotcha.
particular condition.
Thank you for clearing that up.
Alright, so this one's the same. You import the PE module. And for this one, I'm looking for a file that has 3 sections and is an executable image. Right? So that's going to return any file with 3 sections, exactly 3 sections, and is a PE executable file. So that's just examples of using the modules and only conditions. The other one we talked about are strings. So this is the basic rule with some strings data. So we're looking for this particular string in the binary, well, all these particular strings. I showed you here, 02 has domain without the full word modifier. This rule will match any word with domain in it. This rule, S03, is going to match only the word domain. So that's just to show you guys the difference. This here is going to search for any word with just this is a string, and it can be ASCII or it can be wide. So this is a lot more flexible. Gives you a lot more flexibility. So here we talked about the byte distance. Right, so here's a sample of the data chunk I'm looking for. Right? I have my string identified as the first 4 bytes of that data string. I don't care what happens in between here, but I know that 10 bytes later, always I'm going to see 8899. So how do I write that? There's a lot of ways to write that. In a condition, I can write for all of the strings A, unsigned integer 16, the @ symbol identifies the current location of A. So when A is matched, this particular identifier is going to have the location of that string. And 10 bytes from that, I have to see 9988. Now, I wrote it like this because if you guys know the difference between little and big Indian, in memory it's going to look like this, but in actuality, you know, the integer is going to be reversed.
Do you have oh, sorry.
No, go ahead. Questions?
So the @ is the pointer
For this, for the string A.
Does it have another character for the offset for where it ends, where the string ends, or you have to calculate? Always?
Yeah, it calculates from. That's actually a good question. I think it calculates from the end of that pointer. So it's going to calculate from this position at the end, and then you add the 10 bytes. So you have. No, actually, I'm so wrong. It's the beginning.
It's the beginning.
It's the beginning.
So it doesn't. You don't have built-in a character that tells you where the string ends.
You can the A identifier is 4 bytes, but I see what you mean. If you want to make sure that, but why would you use that? How would you use that? Because you have the string data here, which is 4 bytes. Every match of this 4 byte sequence, the pointer will be at the beginning, and then it'll count
10, right?
10, yeah. I actually have it wrong. It's actually supposed to be 16.
Because I might want to look for something that's after the end of the string, not the beginning, right?
From a relative distance
Yeah,
from it, or right after?
He was saying, like, if you know that the C2 starts with C2 host, right?
Mm-hmm.
And then you want to get whatever the host name is exactly that. So you want to match here but capture here.
Yeah.
Well, you're not gonna. Yara is not built to capture any data. You have to tell it what to look
It's just
for.
built.
Yeah, it's a signature base. So you're not gonna extract any information from it, but you can probably write a rule where if you find that C2 host,
Dump the next 32 bytes or something.
right,
Instead of-
maybe
instead
you
of
can do
capturing
something
it,
like that.
Just dump it in a chunk.
Right? Or, like I was saying, you can use wildcards. So, for instance, say you're looking for BA, DF, OODE, DD, right? But everything that comes after here might be something you want it, but you're not worried about it because you don't want to match exactly. You can just pass it like that and use that. As your string identifier. Right, so you know that C2 host, and then there's some stuff that comes after, but in the results you'll have the location of that where that happens. And then after that, you look in that location and you find your host name. Right. But that's the beauty of actually modules. You could probably write a module that extracts data like that. Alright, so the modules gives you that flexibility to write whatever you want. So in the conditions, you might be able to write something that says extract dot next 10 bytes, and you can dump that to a file or something. Right? So the modules gives you more flexibility. Yara is just signature scanning. You know, they don't want to put too much into it, then it becomes a tool that you don't understand. So they let you modify it the way you want.
And this Sublime extension, you wrote it, or it's available?
What's that?
The Sublime extension is available, or you wrote it?
For the color syntax?
Yeah.
Yeah, it's available. Yeah, Sublime has it's not good, but it works. Yeah, because they kind of screwed up with the quotations and stuff. You'll see some of the rules get messed up. But another way to do this in just the strings is just like this. Right? You can have the next 16 or next 14 bytes as this, and you can look for that sequence. Right? So ignore everything in here, but make sure that 16 bytes after. Right. And it works in a nibble case. It works in nibble case, so you can have something like this, right? Yeah. So it works on nibbles. It doesn't work at the byte level. It works at the bit level. So that's actually really good. Let's see. We have some other examples here. This right here is an example of a compiled rule. Right? After I ran, I don't want to mess this thing up again.
So you said the compiled rules are the ones that you want for performance.
Performance. If you're running a rule multiple times, a lot of times, you want to use it in its compiled format. Alright, and that's just this rule here. So this rule is interesting. I wrote this rule the other day for a piece of malware. So there I have the MZ, which is the
terminal.
seriously, but it should go away after a while. Okay, cool. All right, so for here, I'm looking for this signature at the beginning of the file, which is the MZ header for a PE file. And then I'm matching this byte sequence. Now this sequence, after doing analysis, I know shows up only in the first 100 bytes of the entry point of the program. So only where the program actually starts executing. So between that point and 100 bytes chunk, this sequence of code happens. So that's the only place I want Yara to look for that sequence of byte. And so I use the A in range. So I use that range, and then match all these other hex strings, and it has to have all three of these. So this rule is specific to this particular malware. So I can send that up to a friend in AV and say, hey, run this rule, see how many samples you can get. And so it'll capture that particular malware, because this is a unique identification for it.
So what you're doing there is optimizing, because you want to find A first, and then you match BCD.
Yeah.
But you
So
could,
it's an AND condition, so all these conditions have to be met.
yeah, so you could put in an A, B, C, D in that. It's the same. It's the same.
Well, if I put AND all of A, B, C, D, it'll search for this instance of A in the whole file. Now, the reason why I don't want that is because this sequence of bytes might show up in other places.
So A has to be there.
A has to be
BCD
in this
can be
range.
anywhere.
Yeah. A has to be between the entry point and 100 bytes chunk after the entry point. If it doesn't show up there, it's not my file. I'm not looking anywhere else.
And then find the rest.
Yeah. So it'll find these regardless, even if this condition turns true and this doesn't. The condition's false, right? Because it's an AND. Everything has to has to equate to true. Okay, I showed this one. This was the one I had in the PowerPoint, where I found a lot of interesting string data, but some of them were questionable. So I was like, okay, VB Run might show up in any Visual Basic file, but I am looking for a Visual Basic version of this malware, so I'm gonna have that in there. Browser Facebook, that's obviously not gonna be in every file, right? Because it's particular to that malware. And
meth call engine. What is that?
I don't know.
That's weird.
Oh, actually, that's a Visual Basic stub.
Oh yeah.
Yeah. But the idea of only matching 8 of these strings is I want to match over 50% of these strings.
Yep.
And so I picked 8 as just an arbitrary number.
You find other patterns.
Right. So if I said all of them, it would kind of constrain my search, right? So all of these strings might only show up in the particular malware I was looking at, right? And if they modified it and one of these strings disappeared, I'm missing out on a whole bunch of similar malware. Black shades.
What?
Black shades.
Oh, really?
Yeah, this is what I wrote.
Stuck in Facebook?
Huh?
You was looking at Facebook stuff?
I mean, it was a rat, so it was.
That's
it
how
was
it's spread.
getting a lot of data.
That's one of the ways that it spread. They wrote it was like a watering hole attack that they did. They put it on Facebook, and then a whole bunch of people started downloading it.
Yeah. So, I wanted to match 8 of, and you'll see the asterisks here. This is interesting. So if I write all my rules with S, and then number them, I don't have to write 8 of S01.
Yeah.
I can just put the asterisk and it matches all of the strings that match that particular identifier.
Really easy.
Right. So let's look at one that's for. So this is for Linux based. This is for the IP tables. Right. This is one I wrote for IP tables, and you'll see here I have the ELF identifier. This is the first sequence of bytes that identifies an ELF file. So I want to make sure I'm only looking at ELF files, right? Because anybody can write a text file with all these words, and it'll match, right? So I want to make sure that that matches that first one, and then I have all of these strings and 5 of these strings. Now the reason why I used only 5 of these strings was because, again, if I have all of them and one of them changes, I might miss out on a hit. So I never particularly like using every single string that I find, especially when it's something like source code.
Those are all very used libraries.
Right. So they might compile it with a different set of source code, and I'm gonna miss out on that.
Yep.
But this is actually not something I do. This is like my first rules, so I don't do this anymore. If I see source code names, I try to avoid them because that's just that's probably just a programmer error. They compiled it with all the debug symbols. They can just flip one switch of the compiler on, and all of these are gone. All right. So I don't do that anymore. This is a public rule. I didn't write these, but I wanted to show you guys just how it looks when you use more than one rule in one file. So when you run this in YARA command line, it'll process all these rules, and it'll look, for all of these.
It's going to be a or of each rule or and?
It's going to match. They're independent of each other. One doesn't matter. If this matches, it'll tell you matched this string at this for this file.
Is it gonna do?
It's a or.
What is it gonna do? So, I imagine YARA will take these rules, compile them into its detection engine, and then it'll run through each one of the binaries. Is it gonna do? Okay, I run through all these binaries and I found this first rule. Then I'm gonna run it again and do the second rule.
Yeah.
Okay.
All the rules are independent of each other. And this is where the flexibility of tags. So if you add a tag here, or an external variable.
If I match 2 rules in that file list, I'm going to see that file twice then, is what I should expect.
Yeah.
Okay.
But then you're also going to see the rule name.
Sure, that hit. Right, I get you.
All right. So you know, so they have IPs here. This was the wiper malware that. Which one is that? The Sony one. So it had a lot of different components.
Strings and FBI advisory. Oh, okay.
Yeah, that's probably
All right,
what
I thought-
I read that.
No, that's the meta tag. That doesn't matter. So you have the different things, and here's one thing to keep in mind is if you're using backslashes, you have to escape them. All right, so if you're using 2 backslashes,
Oh yeah,
it's
that's
gonna
the
be
wiper.
Yeah.
That's the no wiper we're looking at.
Yeah.
Well, you know that they came up with a new one that was it was sprayed by a SMB.
Really?
It was not the one we looked at. I guess is one of them, but there was
The-
another one that was sprayed by an SMB, and it had in the code. It did have like the syntax to log in and the password, the places to put the passwords and everything.
Oh yeah.
Yeah, that one. Yeah, at that point you were not there anymore, but you would have loved that one.
Oh shit, SMB, huh?
Yeah.
Nice.
We paid.
Okay, so I do have some. I don't know if you guys.
So is there like an automation portion of Yara, or do you have to, like, if you're running Maltree, is there an automated portion that will just run this stuff and then catalog it somewhere? Or
You can. I mean, you can do that using the Python library. The Python library allows you to scan files, and then anything you can do in Python. If you match a file, you get that return. So if I match this file, I'll move it here.
We come over there,
If I
okay?
match this file, send it over to this database, something like that.
So text file.
But Yara itself doesn't do that. Yeah. So the Yara executable is just worried about scanning and parsing rules. That's why it
So
provides
you
a
use
library
script,
for you
you
to
use
use.
a scripting language to call Yara to do your automated type.
Right.
But wait a minute,
Yeah.
you can use it with the Cuckoo bugs. That's a way of automating, right?
Yeah, but Cuckoo has code inside of the source code that actually processes.
I was
Oh,
just asking
Yara.
if there was like a David portion of Yara.
Yeah.
Oh.
Yeah. No.
You have to extend it to a way that you end up
Right.
in a sandbox.
Yeah,
That's
that's
basically
true.
doing that.
Yeah. So like there was a project that I had on the PowerPoint where someone is actually using Yara to create an open source anti. He wrote it proof of concept and it works. So he's gonna keep working on that project and it'll be a good project. So it's pretty much anybody. If you write any kind of rule, upload it to that database, and you have a much wider array of scanning instead of closed source and waiting for antiviruses to do their process of updating signatures. You get it instantly with Yara. So, any questions?
Yeah, was you okay?
Oh, wait, it's a binary file.
Yes, I hear you. Is there automated Yara engine creator?
There are some, like rule creators.
There's no rule creators, right?
There are some.
Isn't
Well,
there
but
was
he
that
helps
one
you if you are
website? There was
starting,
that one
you know.
website we found. The guy to generate automated Yara rules.
There's a couple of tools. There's Yara Generator
Oh, okay.
right here on GitHub. The problem with them is that they're going through the file and they're grabbing the string data and then they pick random string data to add as your rule. Because to write a good Yara rule, you have to understand your target.
Oh, of course.
So these generators, they can't really understand how to parse unique strings.
It's doing what it's told, but it doesn't get to discern.
Right. So you're not gonna get the robust rules that you can write by hand. Right. So
But if you have issues with the syntax and the framework, it's good help. I mean, if you know the function that you're looking for, you want to tweak it.
it's a starting point. It's definitely a starting point, but the learning curve for Yara is not difficult at all. Like I wouldn't even.
Some of the strings that you were posting, that you need some sort of a OS architecture and memory knowledge in order to identify that.
If you're gonna base it off just strings, you just run strings on the file. and then you sift through the string. So if you have,
you have to unpack it.
you don't have to unpack it. You can identify it as a packed binary. So I have some samples here, right? And I can run strings on this malware sample. Say I don't know anything about this malware, but I want to look for more versions of it. So I run strings, redirect it to a file, and I'll look for any unique strings, right? I keep scrolling. I don't want to get these gibberish strings. I want to get something that is understandable. So I'll scroll. I don't want this. This is just a basic system message. These are APIs. Now I could use these, but a lot of programs might use these APIs, right? So what I'm looking for is something a little more unique. And here's something, right? I have a project database string, right? I could use this string as an identifier, but I wouldn't use this string because this string can go away if they decide to compile it correctly.
Oh, use Friday.
Right?
Looks like charging.
I don't know what malware this is. I picked it up from VirusTotal, and you know, we can definitely try to write some rules. But if you're gonna do it based off string data, this is really all you have to do.
Is that you just run
You do a
strings
strings dump,
Yeah.
and you look for unique strings. Now, okay, there's a lot of strings in
It
this.
seems like it would behoove you to actually look through the binary before you just write a random rule based on these strings.
So for goodness.
You could also like run it through hex dump, right?
Yeah.
If you see like if it's a pre-packed thing, they might have a huge segment of what's junk at the moment. Right?
Oh, goodness. Yes, this is not
Or
gonna work, is it?
huge empty spaces, which is null bytes, because they're gonna use that to fill it up later.
Sure.
When they break the stack.
Alright, so I guess this guest VM doesn't want to resize.
So how does it feel to have a full license of either? They'll chat.
Yeah, that's like
Please don't chat.
It feels different. So this is the one I wrote that I showed you guys, the Banjori file. This one right here. So I'm going to show you guys exactly where, I guess, the process, right? So MZ is just basic. This is a PE file. This is a Windows executable. Now, the entry point of the program starts right here, right? Now, I'm not worried about what happens here. But here I have a relative call. Now, when I see a call like this, as a malware analyst, that kind of jumps out to me. This just means that this file is trying to do some sort of position-independent code. So what this call does, it saves the EIP so that it understands what location in memory it's running. So that's suspicious to me. So I see this call, and here are the bytes. Originally, I wrote the rule with these sequence of bytes, but what's wrong with that? I have zeros, right? And so I was like, all right, that's not going to be good. Even Yara complained about this rule. This particular string is slowing down the scan. I was like, all right. So I extended it to the next 2 bytes. Now, I did say, oh, this is a function prolog. Don't use a function prolog. But I used it with the relative call. So you have call plus 5, and the call jumps here. So this sequence of instructions is always going to happen because it wants to get the previous instruction pointer, and then and then it wants to save the stack. So I use this sequence of bytes, right? And we can see that right here, 558B EC, and here's that sequence of bytes. This sequence of bytes happens within 100 bytes of the entry point. I did the math, so you guys don't have to worry about it. But all this, I think it's up until somewhere down here. So if it finds this sequence of bytes within the first 100 bytes in the entry point, we have a match. Now, another interesting thing that this malware does is it uses hashes to call APIs. So it doesn't use the API names, it pre-computes a hash of the APIs, and then it grabs them. It has a lookup table. It's very common in malware now. They don't use names because it's much faster to use a hash. Yeah. So I found this hash. It calls this function, which resolves that hash into an API name. And I have this hash. I have other hashes. There's a lot more. There's a lot more other hashes. What I'm particularly interested in is the sequence of instructions right here. Right, so that's just EF right here, E2, 97, BF, and this is just the opcode for move, EAX. So I took that sequence of bytes, which are my B, C, and D. All these are different hashes.
So
I use the next sequence of bytes as well, because I determined that this was significant. Yeah, because like I said, in memory it's little Indian, but
does it flip in the signature?
But I'm not looking for this. I'm looking for the byte sequence. And if you're searching a data stream, you're going to get the little Indian version of that byte sequence. Right. So I'm looking for it in this. In hex dump, it'll look like this. Right. But of course,
and YARA always matches on what would be the hex dump.
Yeah, the data stream. YARA doesn't match against literal assembler unless somebody writes a module for it. Right. So I have this byte sequence. I also have this hash sequence, just pushing this particular hash. And the reason why I included the increase and push here, for some reason it decided to use the hash that's 1 byte less than the actual hash. So you move this hash into EAX and you increase it by 1, that's the real hash. And then it pushes that hash on the stack. So this is a fake hash. So originally I looked at it and I was like, okay, why is it increasing? And then when I looked in this function, I was like, oh, okay, yeah, so
Did they do that with all of them?
I did that. No, I did it with this one only. So you see here, you have to push. So this is the actual
that's what I was looking at.
thing, and I was able to actually rewrite that hashing algorithm and verify it. So yeah, so here it does that, and it has a few other ones. Here goes other hashes and stuff. So I have that relative call and all the hashes, and that's what I want to match to identify this particular malware. Add a malware or using any feel like using it in.
So it's just
yeah. You can pass it. You can pass it any kind of data. Like I call it data streams. I don't like calling it binaries or files. You can use it anywhere.
binary and
Yeah. Binary or cat whatever YARA, and then
That's awesome.
yeah. So it's really nice. A little, just to kind of complete the demonstration.
I mean, you could almost write like a binary search engine, right?
Yeah. It has a lot of potential, just because it's still new. But I know a lot of companies are using it internally, like for some badass stuff. So, for here we have...
You can use this to find all the binaries, libraries, and then use that to exploit those for writing...
you can do any kind of
memory
triage
control,
with
you know what I
it.
mean?
Yeah.
Is that a side project with Google?
So here, I'm going to run the Banjori one against a directory that has all the Banjori samples that I was looking at. And that's how I test to see if the rule works. So we run YARA. If we do help, we'll see all the different options. I usually run standard, print strings, which will print the matching strings, and G, which prints my tags. I use tags a lot just so I know which rules I want to, to filter out the output.
Now when it does the like I saw like the one in the wiper, it had the description as
The meta.
API advisory.
You can
That'll be done.
you can have that if you pass print meta. So if you have M, you can print the meta tag as well. So I run SG, the Android file, YARA, and then where am I? I have to find the
rules.
Yeah, I have to find the directory that my that my malware is in. You can scan recursively. You just have to pass R to the command line. Alright, so in this directory I have all the Benjori malware files, and I want to run this rule file against all the files in that directory. When I press enter, and here we have, alright, so we have all the matches that happened. You'll see that particular byte sequence that I was trying to match, all the hashes that showed up, and all these files matched. That, right?
So what's the hex all the way to the left? Is that the line that it found it?
The offset.
Oh, okay.
This is the offset in which it found that matching string. This is my identifier that I used, and then this is the strings data. Right. So another interesting thing about this piece of malware is that B is always I think 23 bytes away from A. I could have used that as well.
Sure.
In my hex string, I could have been.
Yeah.
And
23
actually,
bytes
I
on here,
didn't.
match on this.
Yeah, and I didn't show you guys this, but you don't have to put a bunch of question marks. So if I have 1, 2, 3, 4, 5, 6, 7, 8 bytes, here's another tricky thing I can do. This.
And that's an 8-byte wildcard?
Yeah. So this is a wildcard. This is kind of like
a variable thing wildcard. Like,
wait, sorry.
but like if I wanted to
do you can also do things like what was it? Here's another one. 8, 6, 8, or 4, 5. So in this particular byte, you can either have 68 or 45 there.
That's nice.
Yeah.
It makes the conditions easier to write.
Right. It makes the conditions easy to write. That way you don't have to write.
We're missing a curly brace at the end of there.
Where?
Not to nitpick, though.
That was not a real rule. I was trying to write that from there. Yeah. So the strings data, and this is all in documentation. If you want to see all the other cool things you can do with the strings or the conditions, it's one page in the documentation, and then you can just play around with it. So you can write different rules in different ways. It just depends on how you want to write it. I ping the authors to see if there's any performance differences between writing rules different ways. That's a hard question to answer. So
Benchmarking as far as their
there's no probably other researchers have done some benchmarking. I think big AV houses that use a whole shitload of YARA rules have done some benchmarking, but me, I use YARA rules sparingly. I use it on personal projects. So. Yeah. So, any questions, concerns, comments, complaints?
really cool stuff.
Yeah. YARA is a very powerful tool. I hope it gets the mainstream presence that it deserves, because it's a well-written tool. It's open source, so if you want to improve it anyway, just grab the source and do pull requests. Author is really friendly, and he accepts any kind of pull request that you want to get. So, and it's an and that concludes the YARA presentation. Awesome. Let me stop this stream.